Today I'm going to guide you how to do stress analysis by the package Sigma in the Gel Studio. Many students ask me, is Gel Studio a popular software in industry? And from what I know, the answer is yes. However, I don't teach you the software, I teach you the concept, how to do the numerical simulations in geotechnical engineering. So I can have 10 time step here, but for an immediate loading, I often have only one. The first step in numerical simulation is I have to draw the geometries of the domain. So I draw the nodes, the critical nodes for my domains. In a student version, you cannot have more than 10 regions. Actually, the number of regions does not influence on your accuracy, but the locations and the shape of them, which is appropriate and close to the real geometry, will definitely influence on your result. Now, I draw the regions from the node I have drawn before. Here I have two layers. The top layer is clay and the bottom layer is sand. And for your easy understanding, I also draw polygon, which is a quasi building on the top. Now, after drawing, I have to define the material property. For an easy simulations, I use total stress parameters, where I have to input only the Young modulus and Poisson ratio. The clay is often softer than the sand. Now, I assign the material to the desired regions by clicking on it. The next step is I have to define the boundary conditions. So here, already three boundary conditions fixed x, y, and xy. I define a new one, which is the stress conditions. And I have it 100 kPa without tangential loading. And now I apply the load and the boundary conditions to the boundary of the domain. For the right-hand side boundary condition, you can put it fixed xy or just fixed x, depends on your analysis. You will see the difference later. Now I can start calculation. As you can see from here, the deformations is a bit rough, and there are some expansions on the right hand side. So I refine the mesh to 1 meter and recalculate. So now the transition is smoother, but there are still some expansion on the right hand side. Sometimes I don't need the mesh, so I close it. And I draw the label for the Y total stress. You can see that for these boundary conditions, I have Y is almost 0 on the right hand side, and the maximum is 120 in the contour. I also can draw the graph of the displacement and stress based on the set of location. So I select it by Y displacement. And now I select the node right under the corner, the chip footing. I also can change it to the total stress. or the shear stress. However, we don't have the couple simulation, so I don't have any information about the water level. So if you choose the pore pressure, it will tell you no data available. Now we can go back to change the boundary condition to see the difference. So I fix the right hand side boundary condition and the bottom by all directions. As you can see here, there are no expansion on the right hand side, and the maximum in the left hand side is 100 and on the right hand side is 20, and the maximum Y stress is at the bottom corner.